Okay, time for our panel. So it's on enterprise Linux, and Ibrahim, Vice President of RISC, and she works closely with partners on the RISC-V software stack. She'll be our moderator, so please welcome to the stage, Brahma.
Thanks. All right. Well, welcome everyone. It's great to see the energy across the hallways in this room. We have actually a very special moment here. I have all the major 3 distros on the stage with me. This is one of our rare occasions. We are very excited to talk to you and get your insight as Linux distros and how you look at RISC-V as an architecture. So why don't we start with introductions. Jefro, you want to kick us off?
Sure. Am I on? So, I go by Jefro. I work at Red Hat. I am responsible for a number of initiatives around RISC-V within Red Hat, among a few other things. Go ahead.
Gerald or Gerald Pfeifer from SUSE. I've been with SUSE for 22 years. Right now I'm the Chief Technology Officer for Europe, Middle East, and Africa. And I have a deep open source heart. So I have quite some commits in projects like FreeBSD and GCC and a couple hundred in Wine.
Hi everyone. My name is Gordan Markuš, and I'm working with Canonical. You might not be familiar with Canonical, but everybody's familiar with Ubuntu, I guess. And I'm working as a director of Silicon Alliances, which means I'm managing the relationship with our Silicon partners, and we are quite investing heavily in the RISC-V space. My background is also in the side of Linux and embedded Linux with contributions to several open source projects, and it's truly amazing to be here with this community today.
Thanks. While these guys compete in the marketplace, they truly collaborate in the upstream. So that's amazing. So I'll start with our first question. What investments have you made into RISC-V enablement so far, whether that's engineering, infrastructure, or upstream collaboration? Gordan, if you want to kick us off.
Right. Thanks a lot, Barna. We would quantify it in 3 main pillars. The first one being engineering, second one being infrastructure, and the third one being community. When it comes to engineering and infrastructure, we have built out dedicated teams in our foundations, as well as infrastructure and kernel teams, to make RISC-V a fully supported platform. And thanks to the investment we have together with Rivos and our partnership, we're paving the path forward towards RVA 23. If you look at our infrastructure and how a Linux distribution is built, and I think Gerald and Jefro know this best, it's a vast amount of open source that has to be rebuilt. So it's not a trivial task to set up these build pipelines, maintain them, and manage them over time. So we're real thankful for all of our partners, and primarily Rivos, for supporting that. Then we're coming to the last pillar, which is the community engagement, right? We're an active member of RVI and RISE at the same time. But also what we're really trying to do is make sure that people have accessibility to development platforms with Ubuntu on them, which makes it easier for them to consume Linux. It really simplifies that. And that is something that we're doing together with partners such as Sci-Fi, Deep Computing, and SWIN that you might have seen here at the summit today. And inside of Canonical, we have a dedicated community of RISC-V enthusiasts that continuously make sure to improve the experience of not just Ubuntu, but in general the open source projects on RISC-V.
Great. Thanks, Gordan. Gerald?
So what we at SUSE have, or associated with SUSE have, is a project called SUSE, which is the upstream for our enterprise Linux distribution. And there we have a rolling release. It's called Tumbleweed, where essentially there is a release every day, every other day, so 4, 5, sometimes 6 times a week. And there we have enabled RISC-V. And we also have a build platform called the Open Build Service that actually doesn't just build SUSE, it builds all of us and a couple more that has that enabled. And so there is, right now we have this Tumbleweed for RISC-V, and we checked this morning. a colleague and me, and there's 16,400 packages building for RISC-V. In the context of that, you run into problems. So you have to fix things upstream, which colleagues did for GCC, glibc, toolchain, Valgrind. And you run into problems with someone else's code or code that you may not be so familiar with. So then it's about reaching out and helping and coaching some of the upstream developers to fix something that may be specific. And one of my colleagues even ported cloud native management that we have in the context of Rancher to RISC-V. So it's evolving on a daily basis. The question is, when does it reach the enterprise?
And that is a great question. And what strikes me is very much is that it's very similar how all three of these companies are going about in a very similar way. Red Hat has been doing porting for Fedora and working with the community to port Fedora now, I believe, since Fedora 36, so that's several years now. Big shout out to Fuwei on our side and David LT, who's been doing a ton of work on the community side. There's actually a large community out there that has been doing a lot of porting of Fedora, which is about 23,000 packages. And there has been a lot of interest internally within Red Hat as well. There is, we don't have any immediate announcements to make, but I don't think anybody does. But I think that we're very interested to see what happens with RVA-23, with the development of software, with the development of hardware in this space, particularly the RVA-23 server platform that Mark was just talking about. I think that's going to be a real game changer for all of us because this is something that's not probably really well known. We can't just do development on these very large-scale systems with development boards that are sitting on somebody's desk. We really need something that can slot into a data center, behave in a lights-out environment with a BMC, and that we can control remotely, and that is performant enough to build our systems within a reasonable amount of time. And we're starting to see these systems, emerge, and it's really gratifying to see that after all these years.
Yeah, thank you for your continued investment and moving the effort forward here. So on that note, Jefro, what upstream projects is on the critical path for you guys on the RISC-V enterprise readiness? And what are the needs and contributions that we need at this point? And you're talking to developers, so.
Talking to developers, well, the main thing I would say is I really am grateful that we are able to do this in the context of the RISE project. That Barna is very uniquely responsible for. We've been working on RISE now for 2 years, and it is essentially a pathway for companies to contribute resources into the development system to help prioritize what is needed for enterprise, mobile, all of these different use cases. So in terms of specific packages, my feeling is that tool chains are one of the most important aspects because you can't really get anywhere without being able to build things. You need to have the tools sharpened first. I'm sure that my colleagues would have other opinions on that.
I know a few LLVM, GCC developers sitting in the audience, so that's a call out to you. Gerald, any comments?
Yeah, I don't have a list of packages. I would agree. I mean, obviously, kernel, toolchain, everything related to booting. I would reframe the question or a little in that you mentioned upstream, which upstream projects, and that's it. If you ship us a board which has a kernel that's 1.5 years old and a toolchain that's something, and both the kernel and the toolchain each have 300 to 700 patches, that's not really working well. You know, the board may boot with that kernel built with that tool chain. If I look at my colleagues on stage and what we are doing is we are creating one distribution with one kernel and one tool chain. And so the ask ahead or, which packages, kernel tool chain, plus please make sure the patches are upstream. and please make sure upstream keeps working on your boards. And that doesn't just make our lives easier. I think it makes the lives of all of us actually feasible to enter the enterprise space.
Yeah, this goes back to the conversation we were having in the hallway. Upstreaming and keeping that as a uniformity is essential. Gordan, any inputs here?
I don't want to repeat what my colleague said, but I absolutely agree. The kernel and the toolchains are absolutely essential. Then looking beyond that, we think the QEMU project is also very vital, because right now, as we're making the move towards RVA 23, without the platforms being out there, QEMU was absolutely instrumental for us to be able to make that switch forward. In addition to that, we also see the demand in some of the enterprise-specific workloads. So, for example, be that databases or data analytics stacks. So getting through RISE, through a joint engagement inside of RISE, pushing those communities, I think that's going to really make a big difference how people think about RISC-V in the enterprise space, because that's going to be able to connect them to the end use cases they're trying to support eventually.
Yeah, the dependencies is deep and broad here, so we all need to, we thank you for your building that foundation and infrastructure for us to stand on and build products. So my next question is, RISC-V International, that's RVA 23, Mark talked about earlier, whether that's standards or ISAs, what are the key, which ones are key for you as a Linux distro, and how do you look at what's coming out of RISC-V International at this point? Yeah.
Me first? I don't know that, I would speak specifically from Red Hat and say that we're rather agnostic about specific extensions. So I think for us, the process of creating profiles that then lead on to platforms itself is more important than each individual decision that gets made. Because we will implement what the market decides it needs, the market or the community, in this case, being the RVI community that develops those standards.
Yeah, so the uniformity here is important. Gerald?
Yeah, totally. You'll see, I think all of us, correct me if I'm wrong, we usually would ship one kernel and one of everything if we do a platform like RISC-V. From that perspective, it's really important to have rich standards, like a rich instruction set that works well for most things. And yes, I know there's lots of silicon vendors, and you love your very special instructions. Most of the users and most of the operating systems won't use them most of the time. Which means we need the base needs to be as strong as possible. And yes, you go into supercomputing, you go into AI, and then you have very sophisticated users who will invoke special compiler flags, etc., to make a very, very specific build. But as far as what we provide generally goes, there is commonality. And yes, there is things like ifuncs. Is it agreement or disagreement? And hardware capabilities, so that you can have different flavors of functions like main copy, etc. Those tend to be more the exceptions, and the question then is, how do you QA that? Because you run it on hardware A and it passes, but if you were to run it on hardware B and if it then goes through completely different code paths, that means your qualification here isn't valid.
I believe that, simply to echo what my colleagues also said, standardization is definitely key. So the profiles, SIG, the server's platform, as well as the server SOC specification is really key for us to be able to build distributions that are capable of running on multiple different targets and serving a wide segment, because our support and security teams rely on having that uniformity. But then at the same time, we also have to acknowledge RISC-V ability to differentiate and for our partners. So what we're really at Canonical truly investing in is to build the opportunity for people to build separate archives that instrumented that special paths in the code. So we really see that this is not just unique for RISC-V, but we really see a trend where we really want to give the ability for the silicon partners to be able to differentiate. I know it's not an easy task, but I think Canonical is famous for making hard things, not because we enjoy that, but we know it's necessary for the whole ecosystem to thrive.
Great, thank you. I'll ask one more question, and I'd love to turn to audiences so they have a chance to talk to you as well. So looking ahead, where do you see RISC-V fitting into enterprise compute, cloud, or data center environments, especially AI workloads continue to grow here? So how do you see RISC-V? Maybe Gerald, you kick us off?
I would expect initial broader deployments to be where users have more control, like they build their own applications, high-performance computing, and I hate to say that because it's such a buzzword, but artificial intelligence. Those certainly would be use cases where I see. And then I predict it'll take a little longer until the typical independent software vendors, your SAPs and Oracles and so on of this world will land. And RISC-V has definitely something and a lot to offer to those people who do those fine-tuned, high-performance AI, etc. workloads because of the vendor extensions. So used wisely, I think those can be a real asset.
Right, and what we're seeing right now from our partners and customers is that there are three key waves that are probably going to come. The first one being the dedicated accelerators, right? For example, if you're using a data processing unit to offload network storage or cryptography, this is probably first in the enterprise where you will see RISC-V deployments right now, because at the same time, the complexity of the software stack is quite minimal because it does like a single function. It's more of an application or an appliance that does something in the data center. Then probably the second wave, which might start in parallel, is the general purpose compute, like hyperscalers or scale-out computing, that will rely on a much broader set of open source packages. And this kind of, all of us together are kind of working on fixing that. And then the third one is actually sovereign high-performance computing and AI. Why I mentioned it as being sovereign, because at the same time, all of us are investing quite a lot to achieve standards such as FIPS, NIST, and so on. And if we build things for RISC-V, we will also have to go through the same certification process, right? So this is also something we will kick off in parallel to ensure that AI workloads can be done also locked in cryptographically, depending on the region it's running on, right? So I see this also as like a third wave that's going to come quite soon.
Those are very much smarter answers, I think, than I have. The way that I look at it is the market segments that are going to be interested in RISC-V are the ones that take a specific advantage over from an open ISA versus a proprietary ISA, and that's going to be different for each market segment. If you look at something that is highly regulated or something that has a long history of tradition with a specific kind of architecture, I think that those are going to be moving a little bit more slowly. But as my colleagues have said, HPC is a highly agile and academic environment, and I think that the openness of RISC-V is going to enable a lot of creativity there. From what we have seen working directly with RISC-V International, automotive, which is going through a very large transition or a transformation right now in terms of technology, I think that that's going to be a big one. Certainly the data center will be moving along because all of the software is going to end up being built on data center hardware. So I honestly don't see any market segments that are going to really be left behind.
Yeah, and RISC-V being scalable and modular definitely gaining traction in that space. Thank you all. So why don't we turn into audience, and this is your chance to really learn how these major Linux distributors are prioritizing RISC-V and where do they need maybe help from you?
Yeah, so my question is about the 32-bit support. At least Canonical does for ARM. I think they are going to support for 12 years LTS. But I think the 32-bit for RISC-V, there's a lot of platform there. If you ask developers, some people are so proud of running on ESP32 Linux even. So I think there's a gap there. Alpine and all exists, but I think at least Canonical, which is so much active on ARM7, should also support RISC-V IoT for 32-bit processors?
Right, and thanks a lot for raising that question. I think it was coming back to the topic that I mentioned at the beginning. From the infrastructure point of view, for us to have a rebuild of RISC-V on a 32-bit platform is counted in several millions, and definitely it's not an easy task. So that's why we have to be very mindful, because once we produce something, we expect it to maintain it for the next 12 years. So unfortunately, I wish there could be a community clone that somebody would do so that they could use it. But unfortunately, Canonical, if we decide to do it, then we'd have to attach to it the enterprise-grade SLAs we normally attach, and that right now is not viable to do, unfortunately.
One thing that I would add, and I will put on my my Yocto, I don't have a hat, but I do have a Yocto project shirt, so I will speak briefly for the Yocto project that there is still 32-bit work going on in that community. So even though you may not get the kind of support that you would get from a company like Canonical or SUSE or Red Hat, there's still plenty of work to be done and plenty of community to be working on that with you.
Great.
Yeah, I think we are very consistent on this one. We actually looked into that for other architectures. And decided not to pursue a 32-bit version for that very reason. It's actually doing enterprise Linux is really expensive for us, and to build it, to qualify it, and then the life cycle, which I mean the current release that went out in 2018, I think. End of life is 2038. And the only reason that is so it's 20 years. And the only reason that is sure that it'll not survive 2038 is because it won't survive 2038 because of time T. Exactly. But then, for example, Yocto, there is the open build service where you could actually do pretty much the same. And the beauty is if you use an existing distribution, regardless of which it is, it'll be adjusted for RISC-V already. Not to the 32-bit flavor, but in between support for, or historical support for 32-bit distros and RISC-V, you have this overlap where you can hopefully get away with very few additional adjustments.
And with this week's announcement of RISC-V International and RISE collaboration working closely with Yocto, we'll hopefully fill that gap. Any additional questions from the audience? Yep.
So I have one. So you're getting all these specs and you're saying we're going to standardize on everything. How do you then, say, dangle the carrot or use a stick on vendors who are not going to do this properly? Like, I'm sure that people are still going to come along with things that are not upstream or even like their little special things. How are we looking at some way of trying to persuade them that now we really should be doing things these way?
This really goes back to that open source, open collaboration. If you guys have comment to that, maybe.
Maybe I can start then. I mean, it's similar in the Linux and open source space that we're working in today as well. So if you look at, we're all collaborating on the same type of communities, in the same type of software organizations, in the same software trees, and so on. But at the same time, there are things that we do slightly differently. And I believe that that difference needs to be contained into something that's not necessarily commodity. It should be a true differentiator. So that's the same way we look at our partners in the hardware space. They need to do the commodity really well, so things are very easily portable and everybody can enjoy them because that's non-differentiating. So every single time we commit things, for example, in the upstream kernel, it makes all of us better. But if sometimes we're doing something for our own projects or infrastructure or instrumentation around it, that's where we differentiate. And I think that's the same thing we expect from our hardware partners. There is like enough room for them to differentiate without necessarily conflicting with what the mission of RISC-V is or to endanger the portability of software, basically.
Yeah, if it's not upstream, we wouldn't ship it in 99.9% of cases, unless it's a customer-specific fix or something. You know, we don't tell a customer we have a fix, but you won't get it until it's been accepted upstream. That would not be a good. I think none of us does that. But apart from that, yeah, I know at least for the two of us, and probably you, don't send us a 500,000 lines patch set and ask us to just drop it. We can't and we don't want to do that. On the hardware side, I would say it's market forces. You know, compatibility. Ultimately, users choose.
Yes, I would also add that all of these companies, at least I speak from Red Hat, and Red Hat will work with hardware organizations to help you upstream your drivers. That's pretty much a universal. And there are other organizations that can help too if it's something that's a difficulty.
Yeah, and as Mark talked about earlier, the RVA23 really builds a foundation for that, and then hardware vendors can build on top of that to differentiate their products. But fundamentals and our commonalities, we all stand on that ground so that we can build products on top of that. I think I saw a hand in the middle earlier. There. Okay. All right, maybe as the maybe final question here. So as leaders shaping enterprise Linux across various markets, right? Not just enterprise. What is the one message you want our developers, RISC-V developers, to walk away with about the role of RISC-V, potential RISC-V growth here?
Sure. Okay, I can go first. I would say that the primary message is one that we've been talking about in open source communities for at least the 30 years that I've been involved with it, which is this is a community. We build things together up to a certain point. We differentiate where we want to add value, but the community is really where it's at, and that's why events like this are really amazing. That's why projects like RISC-V International and RISE are very amazing, because this is a method for us to all work together in a very specified way. So let's keep up the good work and let's keep on going.
When I looked at like IDC reports showing server operating systems 20 years ago, when I started with SUSE, Windows was much bigger than Linux. And Unix and others were very significant. I had a look at a report like a couple days ago, and Linux is ahead by a mile. Windows is still there, and like rest of the world is very small. And I believe that's due to the power of open source. Everything you said, the collaboration, the innovation, where many come together and drive this. And then we compete in the market space, you know. I hope my salespeople are aggressive with his salespeople and yours, and vice versa, right? But where we build together, that's where the innovation, the foundation is driven. And RISC-V is, I think, the first time in the industry where I see something very similar on the hardware end. So let's meet in 20 years or maybe 10 years and see how that has evolved. But I think together we fare a good chance.
Right, and I think that Jefro and Gerald, you captured that really in an amazing way. It's all about that collaboration. And then truly open, I say, it's truly amazing to see how it would become almost like that Linux of the hardware space where all of us will rally towards, right? And we know best how much work and patience it takes to build this thing up. And like you said, I truly believe that looking at the people around here, that we have all the capability, we have all the know-how, and with a bunch of good work, we're going to achieve our goals very quickly. So yeah, thank you all for being a part of this effort.
Yeah, thank you, Red Hat, SUSE, Canonical, to show us what true collaboration looks like. As I mean, you compete in the marketplace, but you show us what true collaboration really looks like. So let's keep the work momentum going in RISC-V. everything upstream. That's where alignment really matters. And this will get us RISC-V as an architecture to be a first-class architecture. Thanks, everyone.
Thank you. Thank you.